Alright folks, we're working back some more on 9.2, properties of logs. Properties of logs. And the thing we're working on today is these things called log rules. And we have log rules because, in my words, exponents are weird. So, because exponents are weird. So, let's talk about how exponents are weird. If I gave you a problem and I said x to the 4th times x to the 10th, right? We could write all these out, or the shortcut, right, is to add 4 plus 10. So we get x to the 4 plus 10, which is x to the 14th. So this is example 1 of why these are weird. It's not 4 times 10 to give us 40. For some reason, when we multiply, we add the exponents, right? So rule number 2, it's weird. If I said, now division, let's just say y to the 30th divided by y to the 15th. We could write all these out. Subtract.
So I'm going to get y to the 15th power. So instead of dividing 30 by 15 and getting 2, we somehow get y to the 15th. And that's just if you wrote the 30 on the top and the 15 on the bottom, when you canceled 15 pairs, there'd still be 15 y's left in the numerator. Last part, the reasons that logs are weird, or exponents are weird, and make sure you guys leave in space in the middle. The last reason that they're weird is for things like x to the 6th squared. We just don't square 6, we don't get x to the 36. Remember, it means to multiply it by itself 2 times, whatever's in the parentheses, so x to the 6 times x to the 6, which now acts like this, which really gives us x to the 12th, but it is weird because even though we have exponents, so saying 6 times 2 is 12. That's weird. So we have 3 log rules to make fun of the fact that these are weird. Not to make fun of, but you know, to fix the fact, account for the fact that they're weird. So our first rule deals with multiplication. Our second rule deals with division. And our last rule deals with exponents. So let's look at the multiplication one first. Our multiplication, we noticed that whenever we had exponents that were being multiplied, we really just added. So we can say that if we have logs which represent exponents which are being multiplied, m times n, so log base b of m times n all on the inside, that's really equal to just, oops, let me straighten that up for you, that's really equal to log base b of m plus log base b of n. Because just like we added here, we're going to have to add our exponent logs. So for division, when we're dividing, so if we have log base b of, let's say, m over n, and these just represent 2 integers, so for m and n, which are contained in integers. It would probably work for other ones as well, but let's just work with just integers right now. We can say that just like when we divided, we subtracted, we're going to say log base b. So division is log base b of n. So we're going to say log base b of m over n is equal to log base b of m minus log base b of n. So it's going to be subtraction. So last one in here, our exponents one. When we had an exponent raised to an exponent, we multiplied them. So we're going to do the same thing. So if we have a log base b of our answer to an exponent, and it's either written like this, or sometimes it's written like this, and it doesn't really matter either way. Both ways get us multiply the exponent by that original log. Okay, so let's get some examples in here. And keep this sheet handy. Okay, example 1. So example 1 is going to have log base 3 of 2 times 4. So our first examples are going to be what's called expansion, where we have the thing on the left side of the equal sign, and we need to get to the thing on the right side. So I notice that I have some multiplication in here. So I'm going to go to my multiplication rule, if that makes sense. So multiplication, I've got 2 times 4. So I don't have to solve anything. I'm just going to say this is log, look like they have the same base. So base 3 of 2 plus log base 3 of 4. Keep the same base. So same base, same base, same base, and they just get their own log symbol. And we'll deal with how we work this later, whereas right now we need to work on expansion. Okay, example 2, which is still going to be expansion. I'm going to say log
base 10, if there's no log, of 5 divided by 7. I notice there's division with logs, so I go to my division rule. Looks like I'm going to keep the same base, so I'm going to say log of, don't have to write the base, I don't have to write the base, of the top number minus log of the bottom number, and it's that simple. Example 3. We're going to do one last one that involves exponents. We've done multiplication, we've done division, so let's do an exponent one. So log base 2 or base 10 of 2 to the third power is going to be 3, put that number in the front, times log of 2. And that's it. That's all you have to do. Okay, so these 3 were the expansion ones. Let's also do some where we are, they're called condensing. So example 4 is to be condense. So we're going to say log base 5 of 2 minus log base 5 of 5. So we look up here on the right side now. It looks like we have subtraction in the middle here. So go see. That is addition, that is subtraction. This is going to be division. So I'm going to write it as log with our same base. We have to have the same base to make this happen. If we don't have the same base, we just can't use the rule on them. Well, yet. Maybe when you get to pre-cal, you can use the rule. Of 2 divided by 5. Just like when we went backwards, we said 5 divided by 7 is 5 minus 7. If we say log of 2 minus log of 5, that's log of 2 divided by 5. All right, example 5. Let's go for a log of 100 plus log of 1,000. We know that log of 100, if you type this in your calculator, you're going to get 2, and log of 1,000 is going to give you 3. So log of 100 is going to give you 2, and then log of 1,000 is going to give us 3. So we're going to write this as log. It's got addition in the middle, which says it's the multiplication rule. Our same base of 10 of 100 times 1,000, which should be 2 plus 3 to give us 5. So let's try log of 100 times 1,000. And it does. It gives us 5. Fantastic. So we could get 5 here if we wanted to, but right now we're just practicing expansions. So example, the last one, I'll have one challenging one if you want. Example 6 says 5 log base 2 of 9. So we've got a number in the front, which says, I probably should look up here to find the number in the front, which is my exponent rule. So I'm going to have log base 2 of 9 to the 5th, and you can write it with parentheses on the inside, or log base 2 of 9 all to the 5th power. Either of those is considered acceptable. Okay, so here's the challenge problem. And I'm going to put the answer up here in a second. So copy the challenge problem down. So 2 log of 5 minus log of 2 plus log of 3. Okay, pause this right now and try to work this out. And if you don't get this time, that's fine. You've got plenty more practice to make sure we get it right. Log
of 3 times 5 to the second over 2. And that's our answer. Alright folks, let's get our practice on, and then we